Thank you for taking time to watch our video presentation. I'm Boxian. This is our presentation for the Engineering Economics and Project Management course. Our project is titled Development of an Intelligent Remote Mineral Mining System, which explores how smart technology can improve mining operations. We begin with a brief introduction to explain why we chose this topic and how it relates to the course objectives. Here is the overview of our presentation. As we all know then, mining is still important today, but traditional methods are costly, unsafe, and bad for the environment. Our project offers a smart solution using automation, artificial intelligence, and real-time data. This system reduces human labor, cuts costs, and improves safety and sustainability. It also meets the cost goals by applying economic analysis, planning tools, and impact evaluation. Traditional mining uses a lot of labor and energy, which leads to high costs and safety risks. It also causes pollution and damages the environment. Today, with driverless trucks and smart systems already in use, we can improve this process. By combining artificial intelligence, automation, and fast communication, we aim to build a system that is both efficient and safer.
Hi, Dr. Emery Chen. I will introduce our project plan proposal. Our project objective is to develop an intelligent remote minerals mining system. And this project uses some technologies. Those are AI optimization, remote monitoring, and the environmental tracking, uh, which supporting the detect the different minerals and maintain the safety standards. And the next part is about the process of our project. As you can see, which are the completion of the conceptual design, system integration, testing, safety assessments, field deployments, and the final review with the report. According to the process of our proposal, we require to finish four tasks. The first one is searching for basic information for AI mining system, which need to understand how the system works. And the next one is a designed process of the project, which provides the basic idea for our project. And the most important one is the economic analysis, which accurately record the cost and economic risks of the different program in the project. And we finally get the best one. And the final one is a resource authorization and impact assessment, which based on the economic analysis make a suitable plan for our proposal.
My name is Justin, and the way we evaluate the economic feasibilities of our project is through cost-benefit ratio. And we started by analyzing benefits and disbenefits of this project. For benefits, first, we have enhanced worker safety. We can reduce the need for human presence in hazardous and remote mining locations. And the second one is operational efficiency. We can enable 24/7 mining operations through autonomous system. And the third one is cost reductions. We can save significantly in labor costs over the long term and also lower the insurance costs as well. And the fourth one, access to remote or inaccessible sites. We can unlock the potential of mineral deposits in areas where manual mining is impractical or unsafe. And the fifth one is environmental monitoring and compliance. Real-time monitoring allows for more precise evacuations, reducing environmental damage. And of course, that comes with challenges. We have this benefit and also cost. For this benefit, the first one is job displacement. We could reduce demand for manual labors in mining, potentially impacting employment in mining communities. And the second one is environmental and noise pollutions. Practically non-stop mining activities could affect the mental well-being of people, especially during nighttime. And mining can seriously affect the natural ecosystem, which introduce risks to the natural habitats of the animals. And the third one is legal and ethical concern. Regulatory ambiguity and public resistance may arise regarding automations and data collections in industrial settings. And for cost, definitely high initial capital investment and a very high cost for ongoing maintenance and upgrades. We need to continuously having expenses for system calibrations, software updates, and also hardware replacement. And the third one is training and workforce deployment. Additional costs required for training personnel to operate and maintain the intelligence system. And the last one is cybersecurity risk. Remote connectivity exposes the system to potential cyber attacks, compromising safety and data integrity. For calculations, we first identify the monetary values related or associated with benefits, disbenefits, costs, with the justifications stated on the slides. And we're using two methods, even though we acknowledge the fact that if you use the same result, i.e. the acceptabilities of the project itself, and we assume a study period of 20 years and a minimum attractive rate returns of 10% and a salvage value of 1.1 millions. And yes, the result that we use is the project is acceptable. And naturally, we came across multiple alternatives, and we of course wanted to determine which one is the best alternatives. And the method that we use is incremental B2C analysis. And here we have stated four different alternatives. with the estimated monetary saving or cost on the tables on the top left. And through applying conventional B to C ratios with present worth for our incremental analysis calculations, we have the present worth cost and present worth benefits for four of the alternatives stated in tables on the bottom left. And yes, the result is on the right. We first calculate the benefit to cost ratios for alternative A, and the value is more than 1, which means project A is acceptable. We then calculate the delta of benefits over the delta of cost for B to A, and it is also larger than 1, which means incremental required for project B is acceptable. And we do the same thing for C to B, and it means and C is also acceptable, meaning it is better than B. And the last one is for D to C, for the delta B over delta C ratio, and we find out that the alternative D is actually worse or not better than C. And so our final solutions will be project C.
My name is Muhammad Ahmadi bin Arizan, and I will be presenting on resource allocation and scheduling. For overview, resource allocation and scheduling is important to ensure that the benefits such as level cost savings, safety improvement, and operational efficiency can be achieved, and helps to minimize these benefits such as job displacement, maintenance costs, and cybersecurity risk. Onto the project planning process, there are 5 main points. For the first point, scout and WBS, we will design and build a smart mining system, and as shown on the figure on the right side of the slide, the WBS start from system design, hardware and software development, testing, and project management. The second is network, a logic-based project network identified the dependency, and the third is result and cost scheduling. Results are assigned based on availability and cost efficiency. The fourth point is master plan. The master plan lasts for 12 months, and as you can see on the guide chart, it starts from feasibility and planning and ends with final review and report. And final point is risk planning. The project may face risks such as system failure, environmental issue, and public concerns. Next is type of project constraint. There are 3 types: technical, physical, and resource. For resource, the shortage of engineers make it difficult to run multiple tasks at the same time. And for classification of problem, this classification is resource constraint classification because resources are the most critical constraint, followed by cost, and lastly, time is the most flexible as a short delay won't affect the project. In resource allocation method, this project uses heuristic scheduling rules based on the resource constraint classification. Activities are scheduled using rule of thumb that focus on minimum slack, smallest duration, and lowest activity ID number. In resource allocation plan, this section will assign on who and what need to carry on the project successfully. And as you can see on the table, each task has their own specific person that will complete on the task. Lastly, project schedule. The project schedule spans 12 active months with a 20-year life cycle, and we will be using EVM method in this section. After calculating 4-month seed, this indicator suggests that the project is slightly behind schedule with a SPI of 0.93 and over budget with a CPI of 0.90.
Although the system may cost more at the beginning, the long-term benefits are clear. With less labor, fewer accidents, and non-stop operations, the mine becomes more productive and affordable over time. The use of project management tools also helps keep the timeline and budget under control. At the same time, the system helps reduce waste and pollution, which makes it easier to meet safety and environmental rules. In conclusion, these projects show how smart technology can lead mining into a safer, greener, and more cost effective future. That's all for our presentation. Thank you for listening.